Okay, welcome one and all. Advent of Code 2020, day 9. Okay, so before we get started today on day 9, I wanted to hop back to yesterday. I was thinking about this problem more because I wasn't super excited about the solution that I came up with for part 2. So I was thinking about it a little more, and it occurred to me that there's a few optimizations that actually we can make here that are pretty easy, and they actually, on second reading of the instructions, they're actually pretty obvious. So first, I just wanted to go back. So remember what we were doing yesterday. So we're going through this list of instructions, and we're trying to see if we have a no-op or a jump. If we swap those instructions, does that cause our program to halt instead of infinite loop, right? So that's the problem that we were doing. And so this is the method that we came up with in order to do that. And so first thing I just want to do, just to kind of make this a little bit easier to digest, is I'm going to break out a method here. I think this might already be private. So I just wanted to break out a little method here, which is, I'm going to call it check swap, because what it's going to do is I'm going to say, okay, at this index, swap the instruction from whatever it is to the new one, run it, and then give me the results. So I'm checking the swap. So we could say check swap, and here what did I say I'm going to take? I'm going to take an index of which instruction am I swapping. What is the new command? What's the new argument, right? And so what I'm going to do in there is just basically all of that. So here I'm going to say result is check swap, and then what are my values? So I have the index right there. This new argument is, or command is JMP. And then the argument is the argument that I'm going to use, okay? Alright. So that is check swap, right? And let's just see if this is instruction new. So what this is going to get changed to whatever the command gets passed in, that's going to get changed to whatever that argument is. And then the result is going to get returned directly. Oh, and you know what okay, got it. Okay, so that's my check swap, and so then I can replace all this this duplicated code that works the same way right there. This one I'm doing that, and then same thing, instant arg. Okay. All right, so now this is a little bit cleaner. So the thing that I realized where we can optimize this. So let's again. So each time we hit a no-op, we're changing it to a jump and seeing if that works. Each time we hit a jump, we're changing it to no-op and see if that works. So now what I was thinking about was, in what cases is this obviously not going to work, right? In what case do you have a no-op where replacing with a jump is very obviously going to create a infinite loop? And so if we look back at these instructions, they actually give us a hint. They kind of slap you in the face with it, and I'm surprised that I missed it the first time. Which is, if you change the first instruction from no-op plus 0 to jump plus 0, it creates a single instruction infinite loop. In other words, anytime you see that the argument for no-op is 0, don't waste your time swapping that and running the program and seeing if it works, because it's definitely not going to work. That is guaranteed to create an infinite loop, right? So we can go back here and we can say, okay, next if the instruction's argument is 0, right? So just don't even bother that. So we've optimized by not doing something, which is often, that's kind of the key way of optimizing programs. Do less things in it. Okay, and so this is going to complain to me here because there's a method 0. Sure. Okay. So, great. So that's true. And now that got me thinking about what are other things that are sort of obviously not going to work? Or not necessarily obviously not going to work, but what are the sorts of commands that lead to infinite loops in the first place? And so let's think about what do we have here. So what types of commands even do we have? Between jump and no-op, no-op is always the same, right? So it's going to be, it does nothing. Jumps, on the other hand, can go forward or they can go backwards. Going forward gets you to the end of the program. So jumping forward is probably safe to say is not ever going to be the cause of the infinite loop. Jumping backwards, on the other hand, is going to be a cause of an infinite loop, right? So maybe we could even extend this to say if the argument is less than or equal to 0, then we skip it, right? There's no reason to take, I'm not even sure if this is a thing, we could probably check, but if there is any negative argument next to a no-op, then don't even try that one. And so I'm just kind of looking, okay, there we go. We have at least one that we're skipping now, right? So there's 2. Okay, so we're skipping a few. 3. So that's, it's not a huge optimization, but it's something, right? We don't have to look at everything. We know that that's not going to work. Now, on the other hand, when might you want to change a jump to a no-op? It's sort of the inverse of that, right? If it's a positive jump forward, changing that to a no-op is not going to solve any sort of infinite loop, right? Because positive jumps forward, jumps towards the end of the program are not the problem. It's jumps backwards. So here we could say, next, unless dot argument is greater than or equal to 0, right? Because we do want to change it if it is 0, because that in itself is an infinite, okay? And so now in this case, it's the opposite of, in no-ops, we're skipping all the ones that are 0 or less. For jumps, you could skip all the ones that are greater than 0. And so that's just 2 small little, it's not like earth-shattering, but overall large enough instruction set where enough of these things match to make a difference, it's an optimization. And it just makes me feel a little bit more clever than saying that I brute forced it. I kind of like half brute forced it at this point. Okay, so that's what I was thinking about for day 8. So now we can go on to day 7, or no, day 9. Numbers go up. Okay. What do we got here? So day 9, which I've done already, we're going to look at 2 different ways to accomplish this. So first we're going to look at what did I do kind of right out the gate when I was trying to solve this quickly. And then the second thing we're going to look at is I went to Reddit and I was kind of looking at all of the solutions, and everyone kept mentioning sliding window as sort of a type of algorithm to apply here. And I had not heard of that before. I didn't even look it up. I just kind of thought about what they might mean, and I came up with something that I'm pretty sure is what they meant. I didn't read too much into it. I just kind of used it as a bit of inspiration, just to have some fun with it. So we're going to see basically 2 different approaches. And I have to say that I'm not sure. I'll have to check after I make this video if is what I did the sliding window everyone's talking about, or is it some other random thing that I just kind of made up, because I'm not really sure. But let's get into it. Okay, so day 9, encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paper clips. Upon connection, the port outputs a series of numbers, your puzzle input. The data appears to be encrypted with the Exchange Masking Addition System, aka XMAS, which conveniently for you is an old cipher with an important weakness. XMAS starts out by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediately previous numbers. The 2 numbers will have different values, and there might be more than one such pair. Okay. For example, suppose your preamble consists of the numbers 1 through 25 in random order. To be valid, the next number must be the sum of any two of those numbers, right? So, examples of valid numbers, 26, 49, okay? 100 is invalid, right? 50 also invalid because 49 is really the highest that you can go there because it's the sum of your two largest numbers in that range. Okay. Suppose just more examples of what's valid, what's invalid. These are valid, these are invalid. Okay. Here's a larger example which only considers the 5 previous numbers instead of 25 as a preamble, right? So 1, 2, 3, 4, 5. So you kind of just go through all those, and then starting here, this needs to be the sum of at least 2 previous numbers. So we can see here 15 and 35 gets you 40. Or no. 15 and 25 gets you 40. Sorry. Okay. So after the 5, the only number that does not follow this rule is 127. So this rule of it must be the sum of at least 2 of the previous 5, true, 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 all the way till we get to 127. Then it's not true. Okay. So the first step of attacking the weakness of this data is to find the first number in the list, which is not the sum of. So basically, your goal is here. They're telling us you want to find 127. Is the one that doesn't match the rule. So what's the first number that does not have this property? Okay. Let's see what we got here. Bum, bum, bum. So I'm going to pop open a new tab over here. Okay. Advent of Code 2020. Okay. Ruby. Nice. Bum, bum. Okay. Alrighty. Oh, type it into the wrong window here. Silly me. Okay, so what are we doing? We are starting day 9 live.rb. Okay. Alright, so let's start to think about what is going on here. So let's open this up. Okay, so we've got a list of numbers. We're going to skip the first some number, right? So for our actual input, it's going to be 25. For this, it's saying 5, so we're probably going to make that a variable, right? And then we're just going to go through the list, and at any point in time, sum the last 5. Once it doesn't match, we return. So this sounds, it should be as easy as it sounds. So let's create some class. So what are we actually dealing with here? What are they saying? This is our exchange X mass, right? What is it? It's a cipher. It's a puzzle. Our encryption. I'm gonna call it a cipher. Okay, so here's our cipher. So initialize this with some input, which is going to be, what did I do? Ooh, struggling today. Okay. Initialize with some input, and that input is going to return a list of numbers after we parse that input. And we're parsing the input. Okay. What does parse input look like? Parse input. Well, we've probably done this. It's day 9. We've probably done this about 9 times in Advent of Code. We're going to take that input. We're going to split it into new lines by new lines, and then over that we're going to map to y on it. So that's what you got there. Great, so now we have our list of numbers. Then what are we going to do with that? So let's say this method, find first invalid number, right? And then what is the length of the preamble is going to be our argument there, right? So that way we can use this, we can test this with 5 for our tests, and then for the actual solution we can pass in 25, I believe. Yes, preamble of 25 numbers. Okay. So let's see. Let's set up this test while we're thinking about tests. All right. So what does that look like? So let's say day 9 live spec.rb. All right. Require relative day 9 live. Great. rspec describe cipher. Do okay, and then let our input is a big old set of lines. Okay, here we go. That's our input. Okay, and then we do all the indentation dance. I'm sure there's a better way to do this, but I am a little lazy. Okay, so once we've got this, which we almost have it. Okay, here we go. I'm gonna work on my indenting for here docs. It's one place where the editor just doesn't do it for you. Okay, what does it do? It finds the first invalid number given some preamble length. And then so we could say cipher is cipher.new, takes the input, expects cipher.find first invalid number with a preamble of 5. That's going to get me 127. Okay, so that's what that should be there. All right, so let's see if we can figure that out, because we haven't actually implemented that. Okay, so find first valid number. So what do we say? We're going through each of the numbers, each with index do, so number, some index. So right away I can skip as long as my index is less than my preamble. So I can just say next if idx less than, I think maybe or equal to preamble. Let's do that. We can always adjust that. Or is it? No, just less than preamble. Okay. And then, so what are we going to do? The answer is return, let's just call that number, return the current number, if what? If, so out of any of the numbers from the current index minus the preamble, up to but not including the current index, so you take that range, right? So what this is going to give us is the previous preamble number of numbers, right? So from my current index, preamble back from that, excuse me, right? Because it's the previous 5 or the previous 25 or something. So in that range of numbers, so what is it? It is that any two of them have to sum up to what the current number, right? So again, we can use that handy permutation method that we learned about day 2 maybe, and then we're going to say, so this one, it's the answer if it's not true, right? So we can say if none of those things, none of those permutations add up to what is the current number. Okay, and I think that is the whole thing. So let's run that. So we could say rspec day 9 live spec.rb. Okay, what happened? Oh, wrong directory. I wasn't in Ruby. Okay. Okay, so what's happening here? Did you mean numbers? Did I mean numbers? Well, no, I didn't, but I did forget to add the reader for numbers. So that's why I was saying, don't you mean the instance variable? Well, no, I didn't. Okay, let's run that again. Perfection. Okay, and then just for completeness here, I've already submitted the solution, but we can do that here also. So let's see, day 9 live solution. .rb, there we go. And so what goes into here, always forget, what is that little preamble? There we go. Okay. This becomes a 9, that becomes a 9 live. Great. And then so this is cipher.new on that input. And then we're going to print part 1 is cipher.find first invalid number, and this time our preamble is 25. So that's what we're going to do there. Let's run that. Day 9 live solution. Cipher. Did you mean cipher? Did I mean cipher? I meant cipher. Okay. 693.161.78. Was that my answer? 693.161.78. Okay, so there you go. There's part 1. Part 2. The final step in breaking this encryption relies on the invalid number you just found. Well, glad we found it. You must find a contiguous set of at least 2 numbers in your list which sum to the individual number from step 1. So here's an example. So in this above example, the contiguous set of at least 2 numbers is 15, 25, 47, and 40. Right? So contiguous meaning they're all next to each other in this list. It needs to be at least 2, not exactly 2, and not at most 2, right? So it needs to be at least 2 numbers, but it could be 3, 4, 5, 6. There's no limit, upper limit. There's a lower limit. It has to sum to the number we got from the step before. So in this case, once we do that all, right? So it's 15, 25, 47, 40, right? That adds up to 127. And then it's saying here, you need to, out of that range, you add together the smallest and the largest numbers, and that gets you your puzzle answer. Okay? And so this is the part where first I'm going to go through how did I do this right out the gate. Just sort of the first, when I was trying to solve the puzzle as quick as possible. And then we're going to redo it with a totally different approach. No, not totally different. Different approach. Which I was inspired by Reddit and window functions. And one day I'll find out if I actually implemented one or if it's just something else. Okay, so what do we got? Let's say find contiguous range, right? So again, we're going to do this preamble because the first thing that we're going to do is going to call this method, right? And so here we could say our goal number is find first invalid number with that preamble, okay? Or you know what, we don't really need to contain that in here. We'll do that in the test, right? So you want to find a contiguous range that adds up to some goal number. And here we can even be a little bit clearer, like that's your sum, okay? So now how can we do this? So as I was thinking about this, let's just take a look at this example again, right? How do you identify what's a contiguous range, right? So if we're going, we got 35, we got 20, we go and check the next number, 15, right? So as you're going, you're adding these all together. At any point in time, if this equals the number you're looking for, you're done. But what happens if you go to add the next number and now your total is over the number you're looking for? Like, you know that can't be a range. But you know that the range has to be contiguous, right? It has to be all in a row. So what you want to do is you want to slide up this first part, right? So the approach that I took initially is, okay, I'm going to use each number as my starting number. I'm going to try to add the rest of the numbers up until I reach my goal. If at any point I go over, I'm going to restart again at the next number, right? So if a range including 35 doesn't work, I'm going to try a range that starts at 20, and then I'm going to try a range that starts at 15, etc., and so forth, until I eventually find the one that I'm looking for, okay? And so how can we do this? So first, let's say I broke this out into a helper function here. So I said range is, and actually, so if we think about it, what are we doing? We're summing them. So we're actually going to have a separate sum contiguous range. And so we're going to do that. Cool. Oh, actually, and this is going to take, what is that goal number? And then so here we could say range is find contiguous range that sums to some goal, and then range dot min plus range dot max, right? So that's our ultimate answer. And now the thing that we need to solve here is just finding this range. Okay? And so how can we do that? So what I'm going to do is first I'm going to say numbers each with index do num idx. Okay? And so this num is going to be my starting num that I talked about, right? Because I'm just going to see range starting with this, range starting with that, range starting with that, then I get my answer, okay? So this number is my starting number. And so what do I need to do is I want to try out and see what's the rest of the range. And so I broke this out into yet another function. And the reason that I was doing this is it's not super pretty, but basically I just wanted to do early returns from loops, and nested loops with early returns gets messy because you want to break out of just one loop, but the early return statement is going to break you out of the whole method. You could use the break statement for that, but I decided to just make it two methods and kind of save myself a little bit of hassle there. So what I did was I made this other function called complete the range, right? And complete the range takes the index where it's starting. It takes this first number that's in the range, and then it takes the sum that we're looking for. And so what complete range is going to do is it's either going to return the completed range that adds up to our goal, or it's going to return nothing. And so if it returns nothing, then that means we weren't able to find a range that started at this number, so we're just going to go on to the next one. However, if range is present, again, this is where I'm doing the early return out of the each, right? Okay, and so now let's see, what does complete range look like? So this is taking an index, this is taking the first number, and it's taking what we need to sum to. Okay, and so then what does this look like is, so first our range begins with that first number, right? And then what are we doing is we're looking at all the numbers again, but this time it's just the numbers that are in front of us, right? So it's the numbers from the index of that first number in the greater numbers list plus 1 on to the end. And then so we can go through each of those. We can say this is the next number in this range that we hope it is. Then we do, so we're going to add that next number to our range. And now, if only I could spell. Cool. So when do we stop doing that? So we stop doing that if our range equals our sum. So what are we going to do? In that case, we said we're returning that range. So we're going to return range if range.sum is equal to our sum. All right. What else do we stop is if the sum of the range is greater than our sum, then we're going to abort. We're going to say, okay, there is no range that starts with that first number, so it's time to find a new one. So there we're going to do return nil if range.sum is greater than sum. Okay, and so this is what I was talking about here, where if I just put this each loop inside of this other each loop, I wouldn't be able to do these early returns because it would boot me out of the whole method, I'm pretty sure. It's also just a little bit easier to, I mean, this solution is not great, like I said. That's why I'm excited to go into the next one, which is when I wasn't rushing to finish this so that I could get, internet points on some leaderboards. Okay. So what are we going to do? We're going to test this out. So let's go to our tests. It finds the sum of the range that does whatever crazy thing here. So cipher is cipher.new on that input. So then we're going to do, so our goal is cipher's find first invalid number with 5. And then we expect that cipher dot sum contiguous range, given that goal, to equal, what is it? Equal to is 62. Okay. I think that's everything. R spec, day 9 live spec. 2 examples, both worked. All right, so let's go to our solution. Puts part 2 cipher. What is this called? Oh, hold on, I got it. Sum contiguous range. So funny, I can forget method names I just wrote. Okay, sum contiguous range. And what's the input for this is really this. So maybe if I do something like this, invalid is that. Then here, that's invalid. And then here, that's where I want to, okay, pass that in. And then, okay, Ruby, day 9 solution, 9351526. 9351526. Here we go. Okay, so that was my ugly first pass. Really just the second part is ugly. So now let's make it a little bit better. Cool, so like I said, so this is my first attempt. And so what is kind of bad about this, aside from the fact that it's just sort of ugly with all these early returns, and I think that this is kind of this range, complete range thing is not obvious at all why that's happening. So in that way, in sort of a code cleanliness way, it's bad that way. But it's also kind of bad in terms of, you're wasting a lot of time doing things multiple times. And what do I mean by that? So what does my algorithm do right now? It starts with 35. It adds 20 to the array, right? It adds 15 to the array. At each step, it's summing all the items in the array over and over and over again. Then if I hit a point where the number is bigger than I want, I completely throw that all away. I started an entirely new array with 20. And then I add 15. And then I add 25. Like, I've already added these numbers together in my first loop. Now I'm doing it again, and I'm going to continue to do that over and over and over again as I loop through this. So what is a better way that we can do this? So like I said, I was reading Reddit. People were mentioning window functions, sliding window functions, something. I'm not familiar with that, but I was thinking about what could it mean and how could you do this. So I think conceptually it just makes sense. It's like I have a little sort of a window, right, that starts and stops. And as I'm moving this, I'm always trying to add one at the front. However, at a certain point, the sum becomes too large, right? So how can I basically, what I need to do is slide up. So I'm starting at 35. I need to kind of slide up the bottom of the window. If only I could highlight. There we go. Slide up the bottom of the window so that I can continue to slide the top, right? Sometimes you need to slide up that bottom first, and then you can slide on the top. And then sometimes, right, slide up the bottom. And then one of the key things here is, so A, I'm only ever looping over this whole list one time, looking at a number once. I'm not doing this thing where like I start here, and then I start looping through all the other ones, and then I continue on this original loop here, right? So just one loop. The other thing is that I'm not going to sum my whole range every time. I don't need to do that. All I actually need to do is, anytime I grow the front, I add to my total. Anytime I shrink the back, I subtract from my total. So I just sort of have a running total instead of constantly summing up all these things in arrays and building arrays and adding, doing that sort of thing. And so let's kind of look at what that would look like. So really all that needs to change out of here is the implementation of finding the contiguous range, right? So let's just delete all this crap. And let's kind of think again, how might we implement this sort of window concept that we talked about, right? So one of the things of this is that you have some running total that you're keeping track of instead of constantly summing your list. We still need to return that list so that we can do min and max. So we're still going to hold on to that, okay? Next thing we're going to do is we're just going to start iterating through our numbers. So numbers each do number, okay? So the first thing that we do is let's look at our number, right? We have this current range. We might need to add to the front of it. Well, we definitely want to add to the front of it if it doesn't currently equal the sum. So maybe the first thing that we could just do is just kind of like, oh, let's just end things right here if our total equals what we're looking for. So let's just return range if total equals sum. Okay? So just right away, if we've hit the total we want, we don't need to do anything else. What else do we need to do then? Well, so we're going to do total plus gets this number, and then we're adding that number to the range. Okay, so that's like our normal case. However, in some cases, adding the number to that total is going to make our total greater than our sum, in which case we need to first remove something from the beginning of the list, right? And so it's funny because I'm about to write some code where I feel like it's not entirely obvious that that's what you should do if you haven't tried to write it another way first. So just trust me in that a lot of nested crazy if statements died to produce this simple solution, because this wasn't obvious. But basically, because one problem is you could do something, actually let's kind of talk through it a little bit instead of just trusting me, right? What I could do here is I could say something like, okay, so if total plus number is less than the sum, then I know it's totally safe to do this stuff, right? Otherwise, maybe else if total plus number is greater than the sum, and actually, so what here I can do is do less than or equal to, right? Because that's also safe. If it's greater than the sum, then what I'm going to do? Well, this is where it starts to get hairy, because really what you want to do is loop here, because let's say we have a situation. Let's just look at our input, for example. So I'm at whatever. So I'm going and I'm adding. The next number I want to add is 62. Okay. Let's say 62 makes my number too large. So then I want to shrink the front, right? So I cut off 15. Well, 15 isn't that large. So maybe if removing 15, my 62 is still too much to add to my range, right? So then I need to also remove 25. Until then I can finally add 62. Okay? So the problem there is like this becomes yet another loop in here, right? And then you have in here we're going to have like, oh, okay, now that we removed one, now if the total, right? So it gets into be a whole mess. There's an elegant way to solve that, I discovered, which is first, and this is kind of counterintuitive to me, but the first thing you're actually going to do is repeatedly remove numbers from the front of your list until it's safe to add the first one, instead of first doing the check to see if it's safe to add, right? And here I'll show you what I mean. So I could say until, what is this? Total plus number is less than or equal to the sum. Then I'm going to, in here is where I'm cutting stuff off my list. The beauty about this is that you might think like, wait a minute, maybe I don't need to remove anything because I can just add it. Well, in that case, this is just going to be skipped. Nothing in here will happen at all. it'll just go on to what we wrote before, which was total plus gets that number, and then range. We add that number to the range, right? So this case of it being less, didn't mean to do that. This case of it being less works out totally fine. So now in here, what are we doing? In here, we're just going to, in a loop, we're going to say the first number from here is range.shift, which is, it's like pop something off the end of a list, shift gets it off the front of the list. Don't ask, I wouldn't have picked that name for it, but that's what it is. All right. Total minus gets whatever that first number was, right? And so this is just going to keep doing that until this part is safe to run. And that's all there is to it. It's a lot simpler than the first iteration with the multiple nested looping. I think this part is maybe a little confusing, but I think it's simple enough being a single loop that, well, really it's two loops, but looping once around this number. I don't know. I like this one better. I think this is what they meant by sliding window function. Maybe I'll go look up after this video to see if that's actually what it is, or if it's something far more clever. Anyway, now that we've swapped out our implementation of our find contiguous range function, let's run those. Run that. Okay, got the same number. I'm pretty sure my specs are going to pass. Awesome, that passed. So that was the way to do it. Okay, so that is day 9. It's funny how they, in the about section here, they have a whole thing about like, oh, why doesn't they just consistently get harder? And the answer is because making puzzles is hard. So I thought this one was a little bit easier than the one the day before, but whatever. Still had fun. Still learned something. Maybe sliding windows. And let's see what's going on. Day 10 is dropping in half an hour. So we'll be back with that one tomorrow. All right. Have a good one.